So, hold on. Okay, so good evening. We are almost halfway through. Well, I guess we are now halfway through with Introduction to Cuda. Um, and actually, who am I? Why are we here? I'm Christina, data scientist, been around 12 odd years doing this thing. Refreshing myself on GPUs and deep learning stuff because I think a lot in the realm is going that direction, and I wanted to get back up on that. So I'm streaming live every day, usually at 6, sometimes at 7 Central, as I spend an hour studying the content to help hold myself accountable. You're welcome to join and follow along. Last week we were in PyTorch going through the Practical Deep Learning for Coders course. This week we're in Cuda learning GPU programming and trying to wrap our heads around how do we run our models on a GPU in Cuda, which is based in C++. And there's actually an extension, a PyTorch extension that you could use as well. Today, we are going to be using a Python package called Numba. It is Python code to CUDA kernels, and I'm using it to help me understand how GPU programming works. It's meant to help with the lack of abstraction. And so what they've done here is actually, let me go back. There's a Google Colab notebook. If you don't know what Google Colab is, it's basically a bunch of Jupyter notebooks that you can usually run for free in Google Cloud. They do have like a free GPU version, have several free CPU versions, and it basically runs in between other people's time, so it will stop on you. So I am just going to walk through some of those puzzles and try to continue to wrap my head around how do we offload some of the coding. Earlier this week, we looked at Jeremy Howard. He went through CUDA programming, how he puts it into ChatGPT and it spits it out. And it helps for some of the stuff that already exists and how to do it. But if you're research based like him, it kind of doesn't. So that's the trade-offs. So really going through and understanding some of this stuff would be useful on a lot of levels. So that's what we're doing. If you want to follow along, you can just type in Numba GPU puzzles in Google and it'll pop right up as a GitHub notebook. And if you don't mind, just find my profile, like, follow, share, send me a DM, tell me this is horrible, subscribe to the newsletter. Anyway, we're going to get started. And here we're just going to run anyway and download and install the things that we need. That's going to take a minute. I guess while it's taking a minute, I will come over here. All right. And we're going to install our packages. It installs Numba, NumPy, and different packages. We're just going to ignore these warnings. Okay, so implement a kernel GPU function that adds 10 to each position of a vector and stores the vector output. You have one thread per position. It looks like Python, but it's actually CUDA. And you cannot standardize Python tools like list comprehensions. Okay, so can't use list comprehensions or ask NumPy for properties, none of that. So this is looking like Python. It's not Python. It's Cuda. It's just going to think and work like Cuda. Okay, so how does this work? Let's look here. They create a function. They're trying to add 10. And they create another function to test. Fill me in roughly 1 lines. Okay. Tip, think of function call as being run one time for each thread. The only difference is that Cuda thread.x changes each time. So this is changing each time. So I press play. What does this do? Okay, so I need to fill in this part here. So I'm guessing what I want to do is map spec, since we established that we have map spec, and it adds a plus 10. And I think I'm going to put local I in there. Problem check. No. Oh, wait, I'll put A. See, silly me, I didn't see that at A. I'm looking at this. I'm like, the only other variable right here, but the input is there. So, supported operand types for table and int. So this is not an int. So what do we mean? Adds 10 to each position of the vector A and stores it in vector out. You have 1 thread per position. Okay, so A is made here. MP arrange size, out size, comma. Problem test. Oh, no, I don't need that. It's not going to help, I don't think. Or not going to help me understand what it's doing. Okay, so okay, so adds 10 to each position of a vector. That's actually a function, a method. Okay, vector addition. Okay, so they define it. TID. Okay. So I have A size It said size here. Oh. I feel like I'm missing something completely obvious. Like, completely obvious. Thread index. Okay. Thread index. TID. Thread index. Okay. It goes there. So why isn't it? This is a missing package error. Okay. So it says, recommend doing this in collab as it's easier to get started. Be sure to make your own copy. Okay. Make my copy to Google Drive. Okay. I made up my own copy. And what else? Set hardware accelerator to GPU. Let's rerun this. How do I set the hardware accelerator GPU? Okay, let's try that again. Oh, what I did, I went up here and I'm just changing the environment. It was CPU to GPU, so you don't have Cuda in here without GPU. And so I am going to assume that's what we need. I'm going to run this code again. Okay. Now what am I doing? Fill me in, out. Failed in CUDA mode pipeline. Map spec. Cannot determine number type class function. I don't know what we mean by this error. Okay, no, that was right. Let me go back to, okay. So index ID plus 10. They give us the size. Size, you pass the thread as well. Okay. Okay, that looks different now. Why is this still failed? Return call. Map test. It passes. Map spec by itself, maybe? I'm actually not sure. These are the most loose instructions. Because this is the only math section, so they import everything. They have the index, which this is the index. It said its index, the thread index. So they'll fill me in roughly one line. Am I doing the vector math myself? So this is the problem, right? Um, so map spec a plus 10 stores in the vector out. Return call. Right, so it's going to return this function. I pass out and I pass a. Out and a. Well, maybe Gemini will work. Actually, I don't know if I want to open Gemini on all of my notebooks. So, cannot determine number type of class function. Untype global name map spec. How old is this notebook? Maybe it is too old to use, but we're going to doubt that. Let's find the solutions. Puzzle files. So I guess I'm redoing it with plus 10 again. Or does this not even matter? Well, that's frustrating. Why is it there? I guess I don't understand what the map spec is there for. If I'm just redoing the math again, why do we need it? I need to understand because they don't tell you to not touch it. But that feels like it's giving you the answer. I don't think that makes much sense either. But if it's the answer, it's the answer. Here's the answer. So why is map spec there? I feel like I'm asking questions that I'm not supposed to ask questions to. Okay. Yeah, I don't understand why map spec is there. Is it just to tell me an example of how it's supposed to be? Really would have helped if they noted that. So I'm going to assume it was just supposed to tell me what to do. But if I don't understand vector math and how to add, I'm not sure it's wise to do this. Okay, so if this is the spec again, then am all I doing is this? Oh, I'm not typing that again. Hold on, maybe I should switch it the other way. No, it doesn't do anything different. What were my instructions? Implement a kernel that adds together each position of A and B and stores it in out. Guess I should read my instructions. Yeah. We have a visual. So that is the math going by the thread index, which makes sense if it's just a vector to vector, but I mean, we're dealing with more than that, and that's where I think the confusion comes in for me. Okay. Adds 10 to every position of A and stores it out. We have more threads than positions. So, one, I'm copying from all the way up here again because it's basically this. And then something else has changed. Okay. Implement a kernel that adds 10 to each position of A and stores it out. You have more threads than positions. This is the thread. Okay. So there's two lines to this. So let's go back to, they don't give us spec anymore. Okay. Let's see. Position of the element in the array is the position of the point within the object. Make sure these are identical. Yeah. Out over was 10. Oh. As long as the thread's less than the size. To check for the sizes, they have to be identical to do any vector math. Gotcha. And actually, let me close that tab. Because I have more threads than the size, it's not even, and it can't do anything beyond that point. And we learned that in the PyTorch course. So we need to cut it off and shape it so that it can actually do the math. I think it's kind of cool that you do a little video animation when you get it right. Okay, so implement a kernel that adds 10 to each position and stores it in out, which is this again, but what is the change? So it's still two lines. Input is a 2D and a square. You have more threads than positions. So if I still have more threads than positions, I'm going to need this, but there will also be a change, and there's no more spec. So the size of A is changed. Do they have information on 2D? No, they have information on square. So just saying it's not a vector, it's a matrix. matrix multiplication. I'm guessing we're going to have to do something if it's in the shape of A. As we do our multiplication across. So if the size is less than that for every K in the shape of A, out plus equal this. And so add a plus equal here. That stays the same, plus 10 here. Oh, that's matrix multiplication. I'm doing matrix addition. I don't want matrix multiplication. 2D heat, because I'm not multiplying. Math and coding are the same. I get that, but it just isn't meshing in my head. It isn't meshing in my head as two sides of the same coin. Like I need to translate my math into code. I don't. So I'm not doing matrix multiplication. Let's go back up here to vector addition. I wonder if I can just do for all. I do for all length of A. But I'm not doing any devices. This is the one-dimensional heat. Well, this is not actually as useful as people make this seem useful. If it doesn't walk me through it, I'm not sure how useful it is. So, okay, this is saying I have INJ. Did I misread that? I did. I have INJ. See, I am so blind. I am so blind. Oh my goodness. I am blind as a bat. Hold on, glasses. Maybe that will help. That will help. Goodness. How did I miss that on this page sitting right in front of me? This is ridiculous. I am now offended by it because I was like, it doesn't look like it. Okay. So we need to do a loop, and let's go back to the matrix multiplication section. We need to add a local J here and here. So, oh my goodness, I am so blind. So blind. You guys are probably just like, it's right there. It's in your face. You guys really should message me. Really should message me when I am this low. Okay? So, and this still, I believe, needs to be, I don't think it'll run. I don't need plus equal. Index 2 is out of bounds, so I need a for loop to loop through if I and J is less than, yep. If I and J I'm so blind. Man. Okay. Here we go. Okay. So now that hopefully my eyes are wider, actually, I might need to make the screen wider. I think there comes a point in every coder's life and they realize they've been doing this for more than a decade and it doesn't matter how young they look, they're old. Oh, this dirt. And should be relegated to the back of the room. Or like double blind glasses. Like, leave the coding to the youth. Okay. Implement a kernel that adds A and B and stores in and out. They're vectors. There are more threads than positions. So now instead of copying and pasting, I'm actually going to type it out. So if local underscore I is less than size and local underscore J is less than size, do this. They're going to have out is going to be local I, local J equal A, B. Oh man, add A local I, local J plus A local, no, plus B. It's a B. Goodness, you got your glasses on too now and everything. Okay. All right. A and B are vectors. That's not a vector, is it? Yeah, that's not a vector. Okay, let's look over here for an example. See if they give me one for broadcasting. So the shape is changed. So size dot reshape size 1. So this is a 2D matrix. I guess we're still doing the matrix addition. But why is there J if I don't need it? I feel like I'm getting skimmed. Wrong number of indexes. Okay, I'm missing something. And I don't see broadcasting on this page, so I don't think that's what we're doing. Just size 1. Okay, I think I know. Or I guess maybe I don't know. I don't see an example. Okay, let's go back to vector addition and read slowly. I don't know. This is not a great example. Reddit, you were wrong. It's not explaining anything to me about how or why it works. So no, I am giving this a 2. And I'm giving it a 2 because it doesn't actually explain how to do anything. It's just there and it makes nice visuals, which would be great if it explained to me how to do things. But since I don't know anything or where to find it, this is actually more frustrating than good. Let me just pull back up the answers. So I can extrapolate if I don't even know what functions I need to pull in to do something, or what I'm missing in terms of how it looks, because yes, I know that if this was math, right, you have a vector of this size, and they turn that size into one. When you come out, you add them together. But how do you code broadcasting? I don't know, because again, I'm gonna have to find a different way to learn. This is not helpful. I might actually end up having to get the book. I thought about putting 0 there. I'm not putting 0 there because the indexes are off when you count from NumPy to um, NumPy to Cuda. Oh, my brain, it burns. And I'm not even halfway through this notebook. It burns. Totally adding Cuda to a resume if I can figure this out. It's worth it to be there. I don't add a lot to it because I'm like, I don't really want to admit that I know how to write in SAS. No, I don't want to admit that I know how to write in SAS. Okay. Okay, so this is just switching the if-then statement. Okay, so implement a kernel that adds 10 to each position of A and stores it in out. Fewer threads per block than the size of A. So this is a block. You have your thread that you had before, and you take the block index by the block dimensions and add the threads, and that's going to give you that block. And what does that actually look like? Y equals mx plus b in my mind. So this is b, the constant, y and x. So you take up these as the first part of the block, these as the second part of the block, and then you have one remainder as the third part of the block. Right, block index, dimension. Index dimension 0, 0, 1, 0, and 2, 0. Okay. Oh, my brain died. I hope this translates back over when I go back into actual Cuda and not Python. Fewer threads per block, the size of block in both directions. So this is what I don't get. I have to make 4 lines. Okay. Gotcha. So if this is the case, so if I do 2 dimensions, I don't feel like this is going to be right. but it's my first instinct. Let's see if we have to the array. Let's go to matrix multiplication. This might be a block. So what is this temp 0? That's only 3 lines. This is only 3 lines. So this is incorrect. But why is it incorrect? It's only 2 lines. They do it. Yeah, JY, so this was right. This was right. It's only 3 lines. I did that. It was right the whole time. Why does it say 4 lines, roughly 4 lines, but it's 3 lines? Yeah, we're still rating this a 2 of a notebook. Let's look at the blocks. This looks like it's doing a grid search type of thing, like when you're in PyTorch and you go across doing the convolution. It gets everything. That's that math. It looks exactly like that in my mind. Okay. See if my brain can catch back up to reality. Add 10 to each position in storage and out. You have full blocks in mind. Okay, so we're going to copy this again. This is going to come up. And I'm going to copy all of that actually, just in case, because I didn't fully read it. Okay. So now we're moving from, you move from thread to blocks to multiple blocks. And now we're moving towards shared memory. Each block can only have a consistent amount of shared memory that threads in that block can read and write to. This needs to be a literal Python constant, not a variable. Okay. So, complicated for sure. Because this seems to sync the threads already. And they're creating a 0 is out and 1 with the 1s for the size. And so let's go look at the shared memory. Let's see. If So do I need to pull out a shared document array? Because it has the Cuda threads. And I guess this is the instruction on how you combine the song. Okay, let's just, because I didn't see anything about sync threads. No, I see it here. So we're going to assume that this does the same thing as that. And this index is this. That's equal to 0. This would be A. No, it would be shared. A equals A. This whole thing is a lot longer than this whole thing. So what do I actually need? It does this for me here. Shared local threads equals A. So it sets A to shared local threads. So this is the same as A. And I have Cuda threads. I'm going to set that to out. We're going to see what this does. Okay. This did not add fully. Let's see why. Go back to here. Maybe I need to look at it this way. Instead, because it kind of did that. Is S size? No. So what am I doing again? Implement kernel adds 10 to E for this name, stores name out. So one of the lines plus 10. So I got it in one position. It's plus 10. So let's just switch this to a while statement. I'm betting that's not a quarter. Yeah. Where's the back? I thought I did that. What did I do? Let's go back. Let's go back to what I implemented before. This is plus 10. What's the difference? Yeah, this is if less than size. That's up here. So why would I need to do that there? He does it again. I don't understand why I need to put it twice. That's going to be my confusion. If that works, why do I put if less than size twice? Right out the door. It's 8. If size less than outline, local shared, local I plus 10. Yeah, that didn't work. It got to 4. Yeah. This is supposed to be a size 8. I'm going to size here. Size, past size. These are great questions I don't know the answer to, that I feel are so overcomplicating something. I did that first. It doesn't matter if it's local size or size. This is the block. Oh, LI. The size of the block. I don't think that picture changed. Unless it's size, so top side, bottom side. I think shared memory is going to give me the hardest time. Okay, I'm going to stop here for the day and see if I can't figure out something that can explain shared memory and that to me. I don't know. I don't think this is going to be helpful for me specifically. It might be helping you, but I think I'm going to pull up something different for tomorrow. Okay. I will chat with you guys tomorrow. You guys have a great Thursday evening. Thanks for tuning in, and be sure to subscribe to the newsletter.